the two small boxes at the edge of each parameter. So what we see is that on this example, par contre, computation time of par contre is much smaller than computation time of LGA2. But we use for LGA2 some default parameters, and we see that there is a lot of points, and maybe by reducing the population size, for instance, we may obtain the same result with less effort for LGA2. And we see that some ruptures. So we have a line there. It's corresponds in fact to active constraint shapes. So here, and there are also constraints here. Okay, another example is the following one. There is two simple linear objectives, but there are some constraints which introduce functions. So here, the Pareto front is a set of optimal solutions is disconnected, and we start at three different points. What we obtain is that we see here that computation time of both methods are quite similar. And we see also that Parkhouse is able to find some portions here and here, which are not found by LGA2, but it is a weighting because those parts are dominated. This is due to the local oriented approach of Parkhouse, which cannot detect at this point that those parts are actually dominated. But it is easy to change a bit the algorithm to consider this in this case. Okay. And last, this is another problem which introduces two big complicated objectives. We have 10 variables and we start at the guess optimal for the second one. Here is a projection into the first three variables in the first three variable space. What we see is that LGA2 produces some cluster of solutions. The Parkhouse is that produce a long path. What we see in the objective space is that what we see first that in terms of computation time is more costly than before. You have 10 variables, and the objective function is a bit complicated. But we managed to find what leads to difficulty of LGA2. For instance, we see that LGA2 here produces some local optimal solutions. And we see what? Because here there is some complicated in the objective space. So here what we see is that Parkhouse is able to depict what are the difficulties inside the program. Okay, so some information about Parkhouse is that each step costs as the cube times complexity. If we compare the methods to non-simplified methods, it tends to use a smaller step size, so we have to use more steps technically than non-simplified methods. It has the ability to produce certified enclosures of solutions, so we have proof that each enclosure contains a unique curve of local optimal solutions, and the process uses only local informations. However, it's very clear that objectives and constraints are twice reproducible, and by now we cannot handle some singularities, and we are still limited to one-dimensional models. To conclude, we are seeing that many state-of-art approaches attempt to parameterize the problem of the multivariate problems, and that configuration method is promising in this vision of solving. And we propose satisfied configuration for the objective problems that is able to deal with rigorously with chain invariant set of constraints. And what we want to do next is to integrate Parkhouse into a global method. We want to be able to find one point per connected components, and let Parcours to find all the solutions. And we want to adapt it to 3 objectives. But this part is pretty complicated because we do not know by now how to connect rigorously 2 parallel tabs if more than 3, more than 2-dimensional manifolds. So thank you for your patience.
For the presentation, I guess we have time for a couple of questions. You have some questions?
Do you try some other bi-objective algorithm, because NSGA2 is genetic algorithm,
Yes.
so it's quite normal that you don't find the optimal Pareto font, but there are many other more reliable algorithms.
For the objective, not much reliable algorithms.
Yeah.
But
Local,
usually,
more local.
people use beta heuristics. So there are better beta heuristics than NSGA2, of course. But it's just for simplicity. NSGA2 is a well-known technique which is always used to compare methods. So it's just for that. But yes, we can use better beta heuristics to be able to find the solutions. But if you want to see other results, you just have to complicate a bit more the problems and see what happens.
And what is the size of the problem that you think is reasonable to consider?
I would say that it depends on the complexity of the problem. And because here we see that it's an n-square time constant for each step. But the number of steps you have to do, it depends on the length of the manifold and also the conditioning of the system. So this depends on the problem you pose. For instance, if you have very simple multi-objective problems, you can go with very high dimension, I don't know, 200, 500, so on. But if this is very complicated, like this example, you will be limited very fast.
I guess I have one or two questions also. If I understand well, you try to apply continuation method in the context of multi-objective optimization, and use also in this context boxes to prove the solution you compute. Okay. So I guess you mix classical methods and continuation methods. So in your algorithm, you start with a regular or classical algorithm, maybe genetic algorithm, and sometimes you switch to box propagation. And what is the criterion for you when do you decide to switch from genetic algorithm to a box
By now,
editor?
it's very simple. We start NSGA2, and when it's finished, we click on solution and tap on the continuation. That's all. The technique is not really integrated into the process. But we think that certified continuation is maybe not useful inside the meta-heuristic, but after. It's better to use it as a post-process. Because during the process, it is better to be able to find quickly new solutions. And to this end, I think non-certified continuation techniques may be better used. But at this end, in the post-process, certification may be a few techniques. Because we can see here that we found we are able to improve lots of solutions to resolve the solution.
And my last question is similar to the previous one. Why not use as benchmark algorithm already an algorithm mixing PSO technique, genetic algorithm with gradient techniques, for example, to have a better solution, refined solution, even if you have no proof and no certification?
Again, it's the same way. If we apply such kind of methods, yes, we are able to produce better solutions than SG2, of course. But if we complicate the problem, we find an instance of the problem where this method not work well, we find the same difficulty. So yes, we can use better techniques in SGA2, just really a matter of simplicity, because in SGA2 the code is easily available and it is easy to tune and do what you want with it.
And the last question, also similar to one of the previous question, you made a nice review of all algorithms and techniques, meta-heuristic and so on, already applied on such a problem. And I guess when you write the advantage and the drawbacks, you did not mention or use the criterion, what is the size of the problem, number of constraints, maybe it's a mistake on my side, number of constraints, number of criterion, size of the area where you optimize the problem and so on and so on. I guess it's one of the most important criteria when you choose to apply one algorithm on another, this algorithm, gradient techniques.
All the techniques are presented in the state of the art are all the different advantages and disadvantages, of course. For instance, I presented the normal boundary compensation, the method which is based on the supply line. In more than 3 objectives, the method is incomplete. It is not able to find any solutions to the objectives. So it is better suited for P objective problems. But actually, except for only few methods, all are able to solve more than 3 objectives. But of course, there are some which are better than others.
Okay. Thank you again.